So today I want to walk you through a vulnerability management pipeline that I built using Python and the Tenable API. The goal behind this was to build something that an analyst or an engineer could actually use day to day. The pipeline pulls vulnerability data automatically, then it cleans it up into something consistent, and also it prioritizes what actually matters. Using things like severity, exploit signals, known exploited vulnerabilities, exposure, asset context, and how long an issue has been sitting around. And then from there, the pipeline also generates outputs that an analyst can immediately work from, like a prioritized remediation queue with the SLA visibility, exploit-driven hotspots, and a dashboard that leadership can quickly understand at a glance. The main goal here is to reduce manual triage work, make risk decisions repeatable, and still be effective even in environments where scanning data isn't perfect. Maybe credentials are limited, or tags are missing, or even asset context isn't that great. I'll start by showing how the configuration drives the pipeline, and then I'll run it end to end, and finally, then I'll walk you through the dashboard so you can see how everything ties together. So let's start here in the IDE. Everything in the pipeline is driven by a .yaml configuration file. This YAML controls how much data we pull from Tenable, whether we run in Delta mode, or and also how risk is scored. It also defines how findings are prioritized, combining severity, exploit signals, known exploited vulnerabilities, exposure, and asset type into a single risk score. And finally, this is where the output locations are defined. So after one run, I get analyst-ready CSVs and the metrics that power the dashboard. That way, teams can tune behavior here without even touching the actual core code. Alright, so once the configuration is set, running the pipeline is just one command. So I already typed it in here. Python pipeline.py config YAML. So if we run this, let's let it do its thing. And then I'll walk you through the 11 stages that it's doing and what it's doing. So once I kick this off, the pipeline starts by requesting vulnerability data from Tenable. It checks whether it's running in Delta mode, calculates the correct time window, and then starts an export job. Tenable handles export asynchronously, so instead of waiting on a single request, the pipeline pulls for status while Tenable builds the data in the background. In smaller runs, this might only take a few seconds, but in larger environments, it can take up to a few minutes, a minute or two, but the logic still stays the same. The pipeline downloads the chunks and saves a raw snapshot, so there's always a traceable source of truth. From there, everything gets normalized into a consistent data set, merged into a rolling baseline, deduplicated, and then also scored. That scoring takes into account severity, exploit signals, known exploited vulnerabilities, exposure, asset context, and how long the finding has been open. After that, the data is formatted and ordered so it's easy for humans to work with, and the normalized findings CSV is ran. Next, the pipeline builds a ticket queue, filtering P0s and P1s, assigning teams, so priority 1s and priority 0s, calculating SLAs, and generating summaries that can go straight into a ticketing system. Once the tickets are in, the pipeline aggregates everything into metrics, priorities, severity distribution, exploit signals, aging, and trends. Those metrics are then rendered into a lightweight HTML dashboard and exported into PDF or PNG formats for reporting. And then finally, the pipeline updates its state so the next run can safely use the Delta exports again. At that point, everything's ready. So analyst data, remediation queues, and leadership-friendly reporting all from a single run. Alright, so then now we can jump into the dashboard. So here's the dashboard. But before we jump into the actual numbers of the dashboard, I wanted to quickly point out the links at the top here. So every time the pipeline runs, it produces real outputs, not just a dashboard. You get normalized findings, CSV, a ticket-ready remediation queue, raw metrics, and a PNG snapshot for reporting. Everything you're about to see here is backed by those files, so this isn't even visual. This isn't just visual, it's an actual operational. Some of the CSV files, just to give you an example how they look like. So this first one is the findings normalized. So here we have everything from the exploit signal to the plugin name to the asset keys. So it's like just the whole deduplicated file all in one CSV. But the one that I prefer like the most, and this is the bread and butter, it's the tickets queue. So here you have similar information, but then at the end we have some exploit, some summaries, either the exploit summary or the full fledged summary with all the information here at a glance, and then also the plugin as well, so you can go back into Tenable and see how this can be remediated. Key report, so it's like a quick glance of the environment metric snapshot. So we have here the counts by priority, the aging buckets, counts by severity, and then the top plugins with the number of affected assets. So this is something, some visualization for management, which they love their graphs. The top with the this is the KPI cards, as I call it. This gives you instant situational awareness. So total findings shows overall exposure. The critical, high and high risk highlight, critical and the high risk highlight what actually needs attention right now. Exploit signals is the CSEC call out findings with real world exploitation risk. And then the age metric helps surface how long risk has been sitting in the environment. In a real workflow, this part of this is the part you glance at first and to understand how bad things are. And then right below that, we have the priority buckets. And we break things down by priority and then also severity distribution. So this helps answer two different questions. Priority shows how we're choosing to treat risk, and then the severity shows how vendors are actually rating it. The gap between those two usually is where good vulnerability management decisions happen. And then the section underneath is for the exploit-driven hotspots. Instead of just listing plugins, Instead of just listing plugins with the most findings, this filters down to plugins that actually have exploit signals. So this tells you where exploitable risk is clustering across assets. It's especially useful when you're trying to decide where to focus patching effort instead of just chasing raw counts. And then next is the SLA breach, which is over here. This looks for at findings through an operational lens, what's overdue or approaching breach based on the risk aware SLAs, and then we change that in the Python code to have the whatever SLA the company has for either P1s or P0s. Criticals or highs in this case. In this environment, they're mostly zeros because this is a testing environment, and then the assets are very short-lived, so it's going to be over 0. But in a real enterprise environment, this becomes a powerful way to spot process gaps in accountability issues. And then going down, next steps is the next actions section, and this is the bread and butter. This is, at least for me, this is the section that I probably spend the most time in as an analyst, because this next action section is a prioritized ticket ready view of what actually needs to be worked on. It's filtered to high impact items, deduplicated, and includes ownership, due dates, and a risk score. You can filter by priority team, and this is coming straight from the Tenable tags. In this case, I only have 2 tags for Tenable, but if your company has more, they'll definitely be here, and you can filter throughout from those tags. And this is something that you can hand directly to remediation teams or plug into this ticketing system. And this is where the pipeline stops being just analytics and then starts being actual execution. And just to close this out, just a reminder that everything you're seeing here is exportable. So the dashboard, the metrics, the ticket queue all comes from the same underlying data. So analysts, engineers, and leadership are all looking at the same numbers, just in different formats. And that's really the point of the setup. One pipeline run, multiple audiences, and no manual rework. And that's the pipeline basically end to end. One run gives you prioritized risk, actionable tickets, and leadership ready reporting, built to be practical, repeatable, and usable on the day-to-day. Yeah, that's pretty much it. Thank you for watching.